Hi, welcome to this video tutorial where you learn Ethers.js by creating a decentralized voting app. My name is Ayuba Ojonugwa Muazu, and in this video tutorial here, we're going to learn Ethers.js by creating a decentralized voting application. So at the end of the day, in this video tutorial, we're going to interact with the smart contracts we're going to create by interacting with the smart contracts through Ethers.js rather than the Web3 technology. Like I said, if you have been on the education ecosystem for quite some time now, you would have watched a whole lot of video tutorials I've done on the blockchain technology and the .NET programming language. I'm a software developer from Nigeria, Africa, and I've been in the software space for about 10 years now. And I'm in the blockchain space. I've been in the blockchain space for about 3 years now too. So I'm here. I've been creating different web apps by instructing students how they can learn real world projects by creating real world scenarios, how they can learn programming by creating real world scenarios. So this is one of my video tutorials, and here you're going to learn Ethers.js by creating a decentralized voting application. So I hope you enjoy this video tutorial at the end of the day. Thank you. Hi, welcome to session 1 on this video series where you learn Ethers.js by creating a decentralized application. My name is Ayuba Ojonugwa Muazu, and in session 1 here we are going to look at the features of Ethers.js and discuss the overview of our voting decentralized application. So the best way to learn about Ethers.js for now is to go to docs.ethers.io, and here you are going to learn a lot about the Ethers.js project. So if we go to get started, you can see what is said here. Ethers.js library is compact and complete JavaScript library for Ethereum. Now, Ethers.js is an alternative to Web3. So it's an alternative to Web3. And so we come here, index.html. The Ethers.js library aims to be a complete and compact library for interacting with the Ethereum blockchain and its ecosystem. So it was originally designed for use with Ethers.io and has since expanded into a much more general purpose library. So it's a library where you can interact with the Ethereum blockchain just like your Web3. But one thing about Ethers.js, it's easy to use, even though it doesn't have a whole lot of features like Web3, but it's easy to use, and it's well documented like we have here. So you can see the features. You can keep your private keys in your client safe and sound. You can import and export JSON wallets with either get, parity, or crowd sale. You can import and export mnemonic phrase, which is the 12-word backup phrase when you're setting up your account on the blockchain, the Ethereum blockchain, and then a whole lot of other features you can see here. So if you hit the get started button link, you can see the Ethers.js library, like I said, is a compact and complete JavaScript library for the Ethereum blockchain. And if you're using Node.js, if you're using Node, you can install it by this npm install save ethers. You can install that on your root directory, and then you can import that like this. So you check whether it has been imported. That is if you're using Node. But if you're using JavaScript, you can use this or this. Now, to include it in web application is very easy. This has been hosted. The script has been hosted here, cdn.ethers.io. So you can just copy the script and add it to your web page, and of course you have access to all the features of Ethers.js. But you can see here, for security purposes, it's usually best to place a copy of these scripts on the application server. But for a quick prototype, using either CDN content distribution network will suffice. So if you want to deploy your application for production use, you can just click on this link here and then place a copy of this on your web server. So if you click on this link, you're going to see the entire codes in JavaScript. So good, so you can copy all these and then just create a file and use this on your web application. So that means if you copy this, you are just going to reference that just the way this is being referenced, like this, just the way this is being referenced, but you're just going to reference this from your local host. Now that is that about just installing Ethers.js, getting to use it. So let's quickly go to the cookbook and see. Now here there are a whole lot of things you can do with Ethers.js, and here we'll just discuss a little. We'll just discuss the accounts, contracts, provider, signing messages, testing, and then React Native. So for accounts, you can see you can get the balance of your account, get your account address. Let me just run you through this quickly. With Ethers.js, you can connect first of all to a client like MetaMask, which we're going to use MetaMask here, or to other clients, different other clients, and then you can connect to the Ethereum blockchain. You can connect to both the testnet and the mainnet. Here's how you can do that. I'm going to show you that in a short while. And then you can query the balance of an account. You can sweep an account into another. You can see here the Jax wallets. This short recipe will cause all these accounts in a single one by sending funds from each account into a single one. So you can actually do this, once with the Jax wallet, and then you can access funds in a mnemonic phrase wallet. So you can access funds in a mnemonic phrase wallet, and then random mnemonic. Often you may simply want a random mnemonic that is valid. It's important to note that not all random sets of words are valid. Okay, you can actually access funds through from a mnemonic phrase wallet, and then you can get your transaction history. So you can actually do that using Ethers.js. Then you can interact with your smart contracts, using Ethers.js. You can return a value from a state changing method, like it's written here. We're going to look at all this where it fits into our application, because the best way to learn all this is to design a real world application. So you're going to see how we're going to use this. So then providers, like I said, you can connect to different providers. You can connect to MetaMask, you can connect to Test RPC, you can connect to different custom providers that you create. But for this video tutorial, we're going to connect to MetaMask. So I'm going to show you how we can do that. And you can see they have a piece of code here that we're going to look at. Then you can sign messages, you can sign transactions. You can sign transactions and send data onto the blockchain. So, and we're going to see how we're going to do that when we call the function to vote for a particular candidate in our application. Then testing. Okay, these are just techniques for testing your smart contracts and smart contract events and all that. Okay, so like I said, you can come to docs.ethers.io and learn more about the Ethers.js library. But to give you an overview, or to give you a quick grasp and an overview of what you can use Ethers.js for, it's the application we are going to design, the voting the app we're going to design. So at the end of the day, we're going to have this application here, voting the app in Solidity and Ethers.js, where we'll have list of candidates or proposals. Like here I have 3 candidates now, or 3 proposals, and then you can select to vote for each of these candidates. So you can just select a candidate, for example, let's say this candidate, and then you click on the vote button, and the candidates and then you vote for the candidates. So we're going to do that. And each account on MetaMask will be given the right to vote. So let me log in. Each account on MetaMask will be given the right to vote, and then a weighted vote value. So it means in our application, if a candidate votes once, he cannot vote again. If not a candidate, rather, if a person votes once, the person cannot vote again. But a voter can actually delegate another person to vote on his behalf. So we're going to look at all those features why we learn Ethers.js doing that. So like I said, you just select a candidate and then you hit the vote button, and then here the vote counts. So the beautiful thing about this, it's a normal voting dApp, but this is done on the blockchain, and then it's publicly verifiable. There is no cheating, and you get to see clearly, transparently who was being voted for, and so you're just going to get to see that. So that's what we're going to create at the end of the day. So we will have different accounts here. Like I have 4 accounts here, so each of these accounts will be given a weighted value to vote, and each of the accounts can select a candidate and vote for that candidate. For example, you can log in with the second account here, and then you can vote for a particular candidate. Say, let's say I want to vote for the second candidate now, and then you click that, and then you should be able to vote for that particular candidate. So that's what we're going to create at the end of the day. So stay with me. In the next video, we're going to create this the app interface, create the smart contract, then interact with the smart contract via the Ethers.js library. So thank you for watching. Hi, welcome to session 2 on this video series, where we learn Ethers.js by creating a decentralized voting application. My name is Ayuba Ojonugwamo Azu. Now in session 2 here, we're going to create our voting the app interface, and it's just going to be a very simple HTML interface that looks like this. So we have a list of proposals or candidates, and then you select a particular candidate, hit the vote button, and you vote for that candidate in a very transparent manner. So, or you delegate someone to do that on your behalf. So we're just going to create this very simple interface, and for me, I'm using Visual Studio, so you can use any text editor that works best for you. I've done this before, but I'm just going to do it again. So I'm going to create a new project or a new website, just a very simple HTML page. So I'm going to select that. Now I'm just going to select, just call this voting the app, and then now, but make sure if you're creating this, you should host this on a local web server, because you can actually run the Web3 part without having this on the local web server. Okay, so I now create a new page, index.html. So create a new page, a new HTML page, index.html. Good. Now I'll also need a bootstrap. Now we can just go to getbootstrap.org. Is it .com? Okay, .com. So you go to getbootstrap.com, and then you can download the latest bootstrap package. So the bootstrap it's just a library of CSS and JavaScript files that you in your web development. So you just download that and get the latest one, in which I have mine here. So I have mine here in my downloads, and then I have it here. So you just pick the CSS and JavaScript files. Okay. So then you add this. If you're coming from Node.js angle, you can, it's pretty much straightforward, just like what I'm doing here. So okay, now I have this. I can add this bootstrap to my, I can just pick these and add this to my application. So I add this link, so the minified version of my CSS file. Now this body, I can just give it this container. Good. So quickly we'll just create a table. Always starts with this, just a h1 voting the app in Solidity and Ethers.js. So this, so you can actually view this in your Google Chrome or any browser that you're using. Okay, good. So I have this. Now a quick prerequisite, you need to have MetaMask installed, so before you can be able to use these follow this tutorial efficiently. So you need to have MetaMask installed, and to install MetaMask is very easy. Just go to metamask.io, I believe by now you should know what MetaMask is. So just go to metamask.io and then you hit the download button, and then you add it to your Google Chrome or your Brave or your Firefox browser. So that is that about that. So from here now we just create a simple table. Just create a very simple table in which first of all I put this in a div. So it's a table, responsive table, so this can fit into a mobile view. So we'll just create a table, class table bordered. So we'll have our t head, and tr, so th, we have candidates, and then we have votes, candidates and votes, just like we have them here in the last one I did. So we have candidates, we have votes, right? Then what's remaining is t-body, just very simple interface. T-body, so we have tr. So the first one, I'm going to have candidate's name. We're going to have 3 candidates, or should we have 2? Let's just have 2 candidates for this video tutorial. So we're just going to have 2 candidates or 2 proposals. So the first one will be well, let's have 3 just in case. Maybe let me see, candidates, the first candidate 0 name, and then td candidate 0 value, right? Candidates 0. Okay, so that'll be the first candidate. So the second one too, like that. Third one, second one too, like that. So candidates. So we're starting from 0, 1, 2, like that. Studio, sorry, pick this. This should be in here. Candidates 2, oh sorry, candidates 1, and then the third candidates tr td id should be candidates 2 name. We'll have this candidates 2. Okay, all right then. So we save this. Let's run this and see. Okay, good. So you can see our table candidates and votes. So we're just going to have a list of candidates here, which we're going to populate it from using Ethers.js, and then the votes count. So okay, so we have that, and then the next thing is to have our buttons where you can select a candidate and vote for that candidate, and like that. So I can pick the select button, select tool, just this. So I'm going to have options. Okay, we're still going to fill all this. So here I will just say option value, select a candidate to vote. So we're just going to have that one, and then we're going to have our button. So first of all, let's just style this button, and then I'm going to put here vote a candidate, or good, so just vote a candidate. What did I put here? Option title, rather. Title should be this. And then value should be -1. So it's just going to be the first value. We'll put value before title. I like doing that. I'm missing something. Okay, so we're going to have that, and then we'll have this button, or delegate someone to vote on your behalf. So for that, we the address of the person, sorry, not reset, pick text. So here we're going to put have the address of the person we're delegating, and then the delegate button. Delegate. So okay, so we have this now. You can just refresh this. Good. So the idea is we're going to have our candidates, list of candidates, and their vote counts, and then we select a particular candidate from this drop down here. We vote for that candidate, or we delegate someone to vote for that candidate. So it's this simple, the app we're going to create, but we're going to see how we can use Ethers.js to interact with the smart contract we're going to create at the end of the day. So thank you for watching. Hi, welcome to this video tutorial where we learn Ethers.js by creating a decentralized voting app. My name is Ayuba or John Azu. In the last session, we actually created our interface that we are going to interact with via Ethers.js. So in this session here, we are going to create the voting smart contract, in which if you have been trying to learn Solidity, you would have probably come across this smart contract, the popular voting smart contract. But we're just going to modify ours a little bit, more especially in terms of the constructor, what we are going to accept. We're just going to modify it a little bit, but that's not the goal. The goal is not to teach Solidity. The goal is to teach you how you can connect Ethers.js to Solidity smart contracts. But again, for those of you that might have a difficulty trying to understand the voter smart contracts, then this is the opportunity for you to understand it, as I'm going to explain each and every part of it. So we are going to create the app and then interact with it via Ethers.js. So we already have this. There are a lot of instances of this voter smart contract that has been created, but we're going to create ours newly, and then we are going to walk through each segment of the Solidity code and explain it. So make sure you go to remix.ethereum.org, and then because we're going to use this online tool to create our smart contract, so against other tools like the Ganache Truffle framework, where we have a lot of installations to do. So I'm just going to stick to Remix IDE as we usually do that. So from here, just go to create new file, and then we're going to call these what should we call this? Let's see, voting smart contract, voting contract, or ballot contract, just anything. Okay, good. So let me say ballot contract. Ballot contract. So, well, by default, if you don't put .sol, it's assumes .sol, but let's just put it ballot contract.sol. So we have this. Now the first thing, if you know Solidity, is to start with pragma, just to tell the compiler what version of compiler we want to use. So as of the time of shooting this video, let's use this latest compiler that we have, just above 0.6.0. Then okay, pragma solidity, solidity, good. I saw that error. Then let's start with our contract. So we call our contract ballot, right? And then so now we are going to do a representation of a single voter. Now each voter is supposed to have a weighted voting weight that we're going to assign to him, that the chairman of this smart contract is going to assign to him. So what it means by weights that will be assigned to each voter means how many times the voter can vote. So we're just going to assign each voter how many times he can vote. So we're just going to call that weight, and then we're going to check whether he has voted or not. And then we're going to also store in each voter representation, we're also going to store if the voter wants to delegate his voting rights to another person. And then we're going to check the number of votes the person has been able to do. So let's create a representation of a voter, and we're going to use this complex type called structure. So this will keep a representation of each voter. So let's do this. So like I said, so weight, we declare weight, we declare check whether he has voted or not, so that's a boolean type, and then address, delegates, to check if he has delegated his voting right to another person, then assign integer votes, check if he check how many votes he has done. Okay, now we've done that, so we're also going to create another structure to get the proposal type. It means the different campaigns. For example, if we want to vote for Donald Trump, Hillary Clinton, and another person, so we're just going to create that structure type, so where we have the proposal name and then the vote count, how many times the person has been voted for. We're just going to put this represent, so the candidate name, we're going to create this structure, the candidate name and the votes. So that's just what I mean. So let's do that. So we'll call that let's follow the proposal. Let's follow the convention that they have. So string name, so it should be the name of the candidate or the name of the proposal, and then vote counts. So we want to know the vote count of this person. Okay, then of course we need a chairman of this voting smart contract. That's the person that will initiate this smart contract and also give voting power to each voter. So we call that person chairperson. So say address, so it's going to be an address, and we can access that public. So we'll say chairperson, and then we map each of these voters. We map each of these voter structure to a particular address. So we store a voter structure for each possible address. That's what we're going to do. So we say mapping address. So we're mapping this address with structure, the voter structure up here. So we're mapping this to each address. So we'll make this public. So, and then we give it a variable name voters. So then we also store an array of possible proposals that we're going to create. So just like the different proposals I created here, like we have Ayuba, Muazu, and Nugwa. These are three possible proposals. So we're going to create an array of this. Okay, so we do that by calling this proposal structure, proposal, and then so we'll make it public, and then we'll say proposals. Good. So now it's time to declare our constructor. So we go constructor, and then we give the voting rights to the account that is going to call these that is going to deploy the smart contract. So give that right to the account. So first of all, I'm going to create a proposal name. So I'm going to store these in an array, of strings. So let's say 3 proposal names. So memory, and then proposal names. So I guess I'm just going to use the names of fruits. So the first one, we can say oranges. So these are the proposals, the campaigns we're running. So whether you choose oranges or apples, or let me choose a tropical fruits, or mangoes. So this is the campaign that we're going to choose. So you're going to choose either for oranges, for apples, or for mangoes. Okay, good. Now the next thing is we make sure that in our constructor the chairperson should be the account chairperson should be the account that is calling this, that is deploying the smart contracts. And then we give that chairperson voting power of 1. So how do we do that? We call voters here, this address voters. So we call voters chairperson. So dot weight, so we're calling this, and then we give them the voting power of 1. So good. Then now for each of these proposal names that we created, oranges, apples, and mangoes, we also append to the end of the proposal array. So we're just going to store this in the array. So let's do a for statement. So for integer I equals to 0, and then I less than the proposal names, which is these oranges, apples, mangoes. So just going to run 3 times. Dot length, length, and then we increment that. So for each of these, so we just proposals that push, so to push into the array. So proposals dot push. So we are pushing proposal So we're pushing proposal name. So name will be proposal names. Where's the proposal names here? So we're pushing oranges, apples, and mangoes. So proposal names. So for each of the for loop, and then the vote count, we make that 0 for now. So the vote count, where do we have our vote count? This is it. Right. So we have name here, vote count here. So vote count should be 0. So for this initial, for the initial constructor. So once we deploy this smart contract, we are going to have a list of 3 proposals: oranges, apples, mangoes, and for each of this proposal we give a vote count of 0. So before the voting starts. Okay, good. So now that we have these, make sure I check my, okay, good. So the next function, we're going to create our first function. We give rights to vote. So we have to give rights to addresses that should be able to participate in this voting. So we're going to give rights to addresses. So we're going to create a function called give rights to vote. So it's a function give right to vote. Just use this capital V, and then I can use this small t. Okay, no, let's use capital T. So give right to vote, right? And then of course we're going to pass in the address as the parameter. So address voter. So we're going to have a list of addresses that we're going to give them right to vote, so that they should be able to participate in this system. So let it not just be anybody can just come into the system and vote. So we give right to vote. So we're going to use the require keyword to check for to do our checking. So for example, if we want to check whether the chairperson is the account that is supposed to give right to vote, so we're going to use the require keyword, and of course we're going to do that. So first of all, let's this is required that the account calling this must be the chairperson. So it must be the chairperson, and then in case it's not the chairperson that's called this, so we throw an error. We say only the chairperson can give right to vote. Only chairperson can give right to vote. Okay, good. And that's that. So we also check that the voter has not voted. So we also check that. So we use the require keyword. We check that the voter, so voters here, check that the voter has not voted, right? So not voted. Check that the voter has not voted, so just say the voter already voted. The voter already voted. Okay, good. Then we also check that the voter's weight is 0. It's still like checking that the voter has the voter is actually we just check that we checking that the voter weight is 0 means we're checking that the voter has not been given right to vote before. So we do that. So require that the voter, so start with this, voter weight is 0, so he has not been given right to vote yet. So before we give this right, so these are all the check-ins that we need to do. So we check that this is the weight is 0, and then finally we assign voting rights to that address. So after doing all this checks, so voters voter weight should be 1. Good. So we give him the voting right of 1, just like we give the chairman the voting right of 1. So now we've created our first function, give rights to vote. Then secondly, we're going to create a function to be able to delegate a voter. A voter can delegate another voter, another address to vote on his or her behalf. So we're going to create that function. So we say function delegate. To create that function now, function delegate. So function delegate. So the address we are delegating, so we'll call that address 2, and then of course public. So first of all, we'll check that the sender we do this. So voter will create a representation of this storage. We call this sender. Now we say voters. This should be a message that sender as the account sending this, account calling this function, and then require that the account has not voted yet. So this requires that sender account has not, the logged in account that is performing this function has not voted yet. So require that sender that we declared above dot voted is not voted yet. So once we check this and it throws an error, our error should go like this: you already voted. You already voted. And the next thing, we also check that the account we are giving right to vote is not we also check that the account calling this does not give itself right to vote. If not, what it means is if we don't do this check that we're going to write now, it means an account can actually give itself right to vote, making its voting power to be 2, and that should be fraud. So we're going to check against that fraud. So we say require that as a 2 account is not the calling account message dot sender. So self delegation is not allowed. Self delegation is not allowed. So once we've checked that, then we do a while statement to check voters that we delegate. So just say while voters to account, that's to address, delegate is not zero address. Why this is true? Well, you still, one thing about this smart contract is you can modify it, and you know, if you have better idea, you can modify this smart contract and do something better. So my Solidity is throwing error. Compiler, let me check where is the error coming from. Something is expected here. Something is expected here, which is this equal sign. Good. Okay, good. So while these we first of all check the two accounts should be the account we are delegating to, right? So voters to delegate, then require that the two is not message, it's not the account sending this, not the account calling this, so it's not message.sender. And then so once we do this, we just put this error found loop in delegation, actually found loop in delegation. Good. So found loop in delegation. So what's error I'm having here? Pass error expected primary expression require that two. This is the two account. Okay, so once that is sorted out, then we have our sender that voted should be true, and then sender that delegates true, and then voter storage delegates should be voters too. Then we check if the delegates has voted. So if delegate already voted, directly add to the number of votes that the delegate it's having. So we'll do this. So say if delegate, that's the address we delegated, if it has voted, if delegate has voted, delegate has voted, so we say we directly add to his number of votes, right? So proposals, delegates, votes, votes count. So we pick the weight of, as the sender, the address that is calling this function, we pick its weight and add to this. So else add to the weight of, if this delegate has not voted. wait, sender dot wait. Good. So these are sorted this out. Now the next function we're going to create is the vote function, the actual voting, where the actual voting takes place. So we're going to create that function. So where an account on Ethereum address can vote for the campaign, oranges, apples, or mangoes. So we're passing in the proposal value. So for each of these proposal, we're going to, like I told you, we're going to have value like 0, 1, 2, and 3, because we're counting from here. The arrays, this is array number 0, array number 1, and array number 2. So mangoes, oranges is array number 0, apples is array number 1, and then mangoes is array number 2. So we're going to do that here. I guess I should give some space. No. Good. Okay, so let's declare a voter structure, storage. Let's call this sender too. So we check voters message dot sender. After checking these, we'll require that the sender weight is not 0, so the account that is calling this still has the right to vote, so has the weighted power to vote. So if not, we throw this error, has no right to vote, has no right to vote. Means this account has no right to vote. Then we also check that the account has not voted before, so we do that. Require that his account, that's the caller of this function, has not voted before. So if he has voted before, we put this already voted. Okay, good. Then of course, after doing all these checks, then send out the votes should now be true. Means the vote is not equal to true. He has voted. Then send dot voted, sorry, not votes, because this is a boolean value. Voted should be true. Sender dot votes. Proposal that's he voted for, so, and then we count that for the proposal. So proposals, we take the array proposals, pick the proposal that's been voted for, and then we increment the vote count plus the sender's weight. So while we're not adding +1 here, it's because in the case where this particular address that's calling this function votes was delegated, you know, let's, in the case where this account is given right to vote with a vote 1 and it's also delegated, meaning it's going to have 2 voting power. So that's what we're adding, the sender dot weights. Okay, good. So that's the function for vote. So let's create another function for winning proposal. So compute winning proposal. So let's compute that. So we're going to do function winning proposal. So say public view returns winning proposal like this. Okay, all right, first of all, let's declare this UINT winning votes count winning vote count should be 0. So we declare winning vote count, and then we do our counting. So we just look through each of the proposals. We look through it and then get the proposal with the highest count. So let's just do that for integer. We can call this p, so 0 to p less than proposals dot length length. So we increment that. Good, we increment that, and then we check if proposal count is greater than winning proposal. So if proposals p dot vote count is greater than winning vote count, then we do this. The winning vote count should be proposals p vote count, and then winning proposal. Okay, winning proposal should be these counts that we counted. Okay, just give a little space here. Now that's that for winning proposal. So the last one is the last function we're going to create is just to announce the winner, the winning name. But you mustn't even call that function, because even from the numbers you're going to see from our dApp, you will already know who has won and who has. You already know who is which campaign is the winner of these. Which proposal is the winner of this campaign. But let's just still code that. So we say function, so we're declaring the winner name now, so either oranges, mangoes, or public field returns string memory winner name. So winner name like this. So the winner name should be the proposal the winning proposal. Winner name should be the winning proposal. The winner name should call this function. Okay, let's look at this undeclared identifier main winning proposal.
Good. So we call this function winning proposal. Now we are done with our smart contracts, and I've explained each of the functions. So and then hopefully we have done this. There's no error here. So the next thing is we can just deploy this smart contract, which I'm going to deploy that now. So make sure you select injected web3 and then select the account. Let me select my first account. Let me select the first account. Good. And make sure you're on Ropsten network or any of the test network and you have some Ether in it. So we deploy this to our test network. So I'm going to select this Ropsten network, my first account. And then that should change here automatically. Good. So I'm just going to deploy this, and we already know our proposal is oranges, apples, and mangoes. So I click on deploy. So this pops up MetaMask. Okay, good. We have some gas fees, so I just go right ahead and hit the confirm button. But if I want this to be faster, I can just click on this edit. Okay, I can see it's taking time to load. Probably I'm having little network challenges, so I'll just click save and use the total gas fee I have here. So I'll just go right ahead and hit the confirm button and then wait for the transaction to get confirmed, get mined, and we get to see our smart contract address. Okay, good. So we have our smart contract address here. Now you can copy this and save it somewhere. We're going to need that later, so I can just copy this and save it to my notepad. So I say contract address. So good. So now I have the smart contract deployed, and I've copied the smart contract address. And of course, if you click this arrow button down, you're going to see the different functions, and then you can call them. For example, I want to know who is the chairperson of this contract. So click and it should show me the address that deployed the smart contract, which is this. Okay, all right. In the next session now, we are going to go into Ethers.js and see how we can interact with this smart contract via Ethers.js instead of Web3, instead of the Web3 technology. So thank you for watching. Hi, welcome to session 4 on this video series where we learn Ethers.js by creating a decentralized voting application. My name is Ayuba Ojonugwa Moazu. Now in session 4 here, we are going to do the core thing that is the reason why we're creating this tutorial here, which is interacting with a smart contract through Ethers.js. And just to give you a little recap of Ethers.js, like I said, it's like Web3.js, but much more simpler, much more compact than Web3.js, and it enables you to talk to the Ethereum blockchain through your web page. So it enables you to interact with your smart contract, your Solidity smart contract, or your just the Ethereum blockchain rather, through your web applications. So and basically just to give you a breakdown, basically if you're interacting with a smart contract through Ethers.js, the first thing is you get the contract ABI, that's number one. Then you get the provider, you know, the provider, whether you're going to connect to the blockchain through MetaMask, through Ganache, through Truffle, through different kind of framework, through Ropsten, through the mainnet. You just get the provider. And thirdly, you get the smart contracts address. Then after you've done that, then the next thing, you will now interact with your contract function. So basically, those are just the 4 things that you need to keep in mind when interacting with smart contract through Ethers.js. Get the ABI of the contract, the provider, the contract address, and then you can call the contract function. And that's what we are going to do for this our voting the app. So if you can recall, we created this interface in the second session. So voting the app, we will say we're going to have a list of candidates here, and then their vote counts here. So, and then we can select a candidate, and then vote for that particular candidate. So okay, all right, let's start first by seeing how we can interact with the framework, the Ethers.js. Now, first thing that you also need to note, if you go to the Redux of Ethers.js, if you come here, if you're using Node.js, you can actually install Ethers.js. You can add it to your root directory or your project directory by doing npm install save ethers, and then you run that. But since we're using a web application, and then we're just going to use JavaScript. This script here exposes the library as a global variable Ethers. Now this script is hosted here, cdn.ethers.io, and is a JavaScript minified version of the Ethers.js library. So we can pick these and include these in our web applications, and that's all that we need. So we just pick this, and then we can drop this here. I think it's in the body tags. That's cool. So we have that. Then the next thing, we can create our own script. And then we can check so we can create our own script, and then we can now check on window load. We can do what we need to do. So you can see, why am I not seeing window that's unload? Function. So we can run whatever we want to run here. So okay, can I just normalize this by just putting this like this? I like to do it this way. It's much more readable to me. Good. Okay, so window or unload, we can just let's just keep this. Now let's create a function where we get our values. So I usually do that. So let's get our vote counts. So I can just call it get votes. So create a function. We call this get votes. And the first thing, we can declare our ABI, like I said, which is the first step. Sorry, I can put in a small letter, ABI, and then we go and get the ABI of our smart contract. So this will take us back to the Remix IDE. So remember, we deployed the smart contract, and then we have a smart contract address here. So you click on Solidity, and then you can see ABI. So click on this to get the ABI value. So we have that, and then we can paste this here. So you can use Uglify to put this in straight line if you want to, but it still doesn't matter. So now we've declared our ABI, we can declare our provider. So like I said, we're going to get a new provider. Now we're going to connect to our provider. Now our provider here, we are using MetaMask. So in a way, we can still run away from Web3, right? So providers, Web3, provider. So we're going to connect to our MetaMask. So we use web3.current provider. So, and our current provider, of course, it's MetaMask. So good, we have this. So now our contract, declare our contract variable, and then that will be new Ethers. So Ethers is the how we can call our Ethers.js library. So it exposes the Ethers. So you can see here, this exposes the library as a global variable Ethers. So that's a global variable we are calling. So Ethers.contract. Ethers.contract. So put in our contract value, then our ABI here, and then our provider. So that's how we easily connect to our smart contract. So we can pick the smart contract. Pick the smart contract address here, and then we just dump that here. So the next thing now is we can interact with our smart contract function. So it's just as easy as that. So I'm going to say the first candidate, so I call that candidate 0, or the first proposal, which is oranges, right? So I can just any keyword, I can say proposal 0. So the first proposal, call contracts, and then we are going to call the proposal, we're going to call this. So we're going to call the structure proposal, and we want to get the name, the proposal name, and count, in which of course when we're initializing the smart contract, we have the proposal names here, and then the count, which we set as 0. So let's just verify that and make sure that's working. So the contract that proposals, it's proposals, right? Let me check. Okay, it's proposal with here's what we're calling actually, proposals. So proposals, as the array we are calling. So let's call the first proposal, which is 0. Let's display that and see. Let's display that on our table, and let's see whether we are correct. So we say candidates 0 name. Let me just change this to proposal name, and then count. So the first proposal name, and then let's change this to proposal count or vote count. Let me change this to vote count. Vote 0 count. So we have proposal 0 name, vote 0 count. Proposal 1 name, that's the first, second proposal. Proposal 1 name. Proposal 1 count. And then proposal 2 name. Proposal 2 count. Good. So let me try and display that. So now that I have this, the next thing is just to simply say proposal 0, then so we just check the function if there's an error and if there's a result, right? So just check for results. So if there's a result, so you can see it's somehow similar to Web3, but just the syntax is quite different, but the logic is the same. So the get element that by ID, get element by ID proposal 0 name, inner HTML, that means if there's a result, let's just display the result. So the result 0. So that will be the proposal 0 name. I can copy this and then get the count for that proposal. Proposal 0 count. Okay, vote count, vote 0 counts. Vote 0 counts. I should change all this to vote actually. It's my bad. Votes 1 count, and then this should be votes 2 counts. Okay, and then this should be the second one that we want to display. Let's run this and see. Oh, so on Windows load, let's call the get votes. Let's check these and see if we are correct. There's no error. Okay, there is an error, so nothing is displaying. I actually suspected this. Okay, can I maybe drop this at the header here? Drop these at the header. So on this, let me check if I'm connected to MetaMask. Okay, I'm connected. Let me try and see why my application is not running. Let me debug a little bit. Let me do some debugging. Let me put a div here and then say ID, let me call it MetaMask. So let me debug a little. Let me start from here. So let me say document that gets element by ID MetaMask. MetaMask. So results working. Okay, so that is displaying. So that means on Windows load the function is running. So let's come and put that here and see. So we know exactly where our error is coming from. Okay, that's also working. This is just my own way of debugging these stuffs and seeing. So after the API, okay, it's working. Let me run this again without placing it anywhere and just make it good, so I can make sure I'm doing the right thing. So provider, let's drop it in between provider and see. Okay, good. So I guess that's where the error is coming from, the provider. So it's not supposed to be Ether, it's Ethers. Ethers. So not Ether. So let's run that again. So the global variable that was exposed is Ethers, not Ether. Okay. And then what's the next thing? I think it's provide Ethers the provider, not providers, right? Ethers.provider. Okay, that's where our error is coming from. Here, we can declare it a variable provider. New Ethers dot providers, actually. Web3 provider, and then Web3 dot current provider. This should be capital P. Yeah, that's capital P, not small p. Just providers. Let's just run these and see. Okay, let's go back to our documentation and go to cookbook. I guess we are just missing something. Let's click MetaMask here. So here is what we're looking for. Okay, let's make this constant. Constant provider. So this is how you can actually connect with MetaMask plugin. So MetaMask injects the Web3 providers, Web3 is current provider, so we can wrap it up in Ethers.js Web3 provider, which wraps a Web3 provider and expose the Ethers.js provider API. So we have this provider, new Ethers providers, Web3 provider. So where am I making the mistake? Ethers providers, Web3 provider, and then Web3.current provider. So this should be correct. Can I run this again and see? Guess I'm missing something. Okay, let's do this, and then let's copy what's here. Paste that. Now run that again. Okay, so what am I doing wrong? I can see result working. So what am I doing wrong? New Ethers, constant provider, same new, same Ethers, same providers, same Web3 provider, then Web3 dot current provider. So I'm surprised everything looks the same to me. So I'm surprised. Probably maybe I would have missed something. Well, if you saw what I missed, then you can just copy that from there. So we have that. Then here, our contract variable. So new Ethers, new Ethers dot contract. I think the contract here, the C is supposed to be capital C. So you have to know Ethers.js is case sensitive. So we can pick this. Still continue with our debugging. So let's run that. Okay, good. So everything is working. So you can see a result working. Candidate, the first candidate is oranges, and the total vote count is 0. So we have that. So we can go right ahead and remove these now. Okay, good. So we're able to display the first candidates. Let's go right ahead and display the second candidate. Put this like this. So it's going to be the same thing. So I see variable proposal 1, that's the second proposal now, should be contract proposals. This as a second proposal, and then proposal 1 now. Then now you can put all these in try and catch block just to catch in your error. It would have been easier for us to debug to assuming we had these in our try and catch block. So we say documents that gets element by ID, proposal 1 name, inner HTML should be this result. So you can see how Ethers.js is very easy to connect to our Ethereum blockchain with to display information. So we're actually displaying information now. So votes 1 counts, votes 1 count, inner HTML should be result 1. Okay, good. So we can end this. So here I say we call the first proposal. Let me just put this. Call the first proposal, and then here call the second proposal, and then we're going to call the third proposal. So good. So oranges, apples, and then what's the third one? Mangoes. So we're going to display mangoes. So we call the third proposal. And to do that is very simple. Following our convention, so call the third proposal. So we start this way. So variable proposal 2 should be contract. The contract variable we declared above, proposals, this. So we'll call the third one in the array, and then we say proposal 2 and so function result, and then documents dot get element by ID proposal 2 name, inner HTML should be results. The first result of that's the first element in the array, which is the name. That's why I put result 0. That's the first element in the array. And then the second element in the array, document.get element by ID, vote 2 count, and inner HTML should be result. Second element in the array. So good. So I believe by now we will have displayed everything. all our proposals. So good. So we have oranges, apples, and mangoes. Now the next thing is to be able to vote for these campaigns or these proposals. Now let's display. Let's go to our select option, and then let's display what we have option. Hope I'm not forgetting this option stuff. It's title and value, right? So value, say the first value, which is 0, and title. The first title is what? Oranges, right? I just want to be sure that this is giving me the required effects, the desired result rather. Okay, that means I'm missing something. Is it okay? No, not title. Here should be where we put the oranges. Not title here. This should be here. I was beginning to wonder, like, what am I missing? So I think this should be in between. Not title, just put value and the text in between here. Let's run this again and see. Sometimes very basic HTML can. Good. So select the candidate to vote. We have oranges, or let's say select a proposal to vote rather, or a campaign or proposal. Let's select a proposal to vote. So we have the first one, oranges, with value 0. Now notice that this value I added here are actually the same with the values of the array we created. We have 0, 1, and 2. So the second one is 1. You can also, as an assignment, think of a way you can make, you can connect this your select tool. This is your select tool from your toolbox. Think of where you can connect these to your smart contract and display the appropriate value and proposal names. Follow what I did in the table as a clue. So apples. The third one is mangoes. Mangoes, capital M. So let's refresh this. Okay, good. So select a proposal, oranges, apples, and mangoes. So we're going to select each one, for example, apples, and then we hit the vote button, and then we're going to vote. Now, the first thing we did, we were actually this first function of getting votes, we're actually calling the blockchain to retrieve value. Now what if we want to write into the blockchain, you know, like voting, for instance? By voting, you're actually writing onto the blockchain. So what are the procedures? We need the ABI, we'll need a provider, then we will need the signer. We need to sign, we need to authorize that, we need to sign the transaction rather. Let me just make it that simple. We need to sign the transaction of which contract, of the contract we want to call. So let's create a function called okay, we can end this here. Let's create a function called votes. So function votes. So we're going to call the votes we want to call this function here, where you can vote for a candidate or for a proposal. So we want to call this function. And if you look at it, we said first of all, you must have rights to vote. You must have not voted already before you can be able to vote. But to keep the tutorial short, we're going to give rights to vote here just from our remix IDE, since we didn't since we're not going to create a function of that here. Sorry, that keeps coming up. Since we're not going to create the function where we give rights here. So what you can think of how you can intelligently do that by creating an admin page on your interface where the admin has can perform these functions like give rights to vote and make sure that the admin is this chairperson. So you can as a clue, you can watch some of my videos I did where I handled scenarios like this, so you can find a way that you can intelligently create the admin page for stuffs like this. Okay, but so let's call this function votes. Let's write onto the blockchain and see using Ethers.js. So first thing, like I said, we need the ABI, and then I can copy that again. Oh, this keeps coming up. Why do I keep going there? So that's a reflex. So we copy the ABI, of course. And the second thing, provider constant. Let me just copy this because I noticed I just have to copy this here. In fact, let me just okay, let's copy that. Shall we make the mistake I made the first time? So constant provider. Then now let's just declare another variable signer, and the signer is just to call the provider. Sorry, signer. We'll call the provider and then get signer. And you can see the beautiful thing about Ethers.js is you can do a whole lot of things here. You can get balance, get gas price, ether price, but this is the function we want to call get signer. The first account, the account that's currently signed in. So we'll initiate the contract, the transaction rather. So new Ethers, that's the contract here. Contract, capital C, remember that. And then we'll put the contract address. Now the ABI as a second parameter, and then the third parameter now, instead of the provider, will not be the signer because we're writing onto the blockchain. So we'll pick our contract address, we add that here. Good. So the next thing is let's declare let's say proposal value, which should be documents. Oops, I didn't make any mistake. Should be documents. Let's get elements by ID. So we want to get the value that is picked here. So I can just say, okay, for you to understand, let me say select. Okay, let me say proposal select. Proposal select. Let's get element by ID. Proposal select. So select dot value. Now we're picking the value of that. So we're putting the value in this variable. And then let's also declare let's say cast votes, and then this should not be contract, and we call the function votes, which is this. I call them this function. Sorry, this keeps coming up. Let me just close this. Calling the function votes, which is this function votes. So function votes, and then if you can remember, we need to pass in the address. So we need to pass in the person we're voting for, the value we are voting, because if you look at here, which proposal are we voting for, so it takes an integer, and then so it's going to be proposal value that we declared here, and we get from our select element. Okay, then we say cast votes, then function. So instead of result, we can say transaction here. Transaction. So document get element by ID. So I can just display this result on that my MetaMask inner HTML should be a transaction. So we just display this as we have successfully casted our vote. So the most important thing is we're calling that function here. So you can see how easy it is to do this. So okay, and that's just how simple it is to call and sign a transaction. So let's try that. Let's vote for a particular proposal. So let me refresh this again. Let's vote for apples and see. So we hit the okay. Now to vote, we the chairman of the, before I hit the vote button, let's look at what are required. It's required that the address is not the person has rights to vote, and then the person has not voted already. But we know that when we initialize the smart contract, the address, that's the chairperson, has right to vote, and he has a vote weight of 1. So he's the only person that has the vote weight of 1 for now. So let the chairman vote as the first person, since I'm logged in with the chairman address, Ethereum address, chairman or the chairperson. So here's the chairperson's Ethereum address. So he's going to vote now. Let's click the vote button. Okay, are we having an error somewhere? I can see that MetaMask is not coming up. So this could probably be like we know, it could probably be some uppercase, lowercase issue. So let's try and debug that. Okay, sorry, I didn't call this function votes. I need to call the function here. Sorry, my bad. Votes. So on click. So we call votes. Okay, so let's try and votes. Let's refresh this. And then say we're voting for apples, right? So let's hit this vote button. Okay, so now we can believe that there are errors. Since MetaMask didn't pop up, so we believe there should be an error. Okay, so let's go back and look at our function properly. Let me check here. I hope the problem is not from here. See result working. Refresh that and see. Select this. Okay, good. So result working up to that point. Then I believe it should be from signer. Okay, Ethers. I usually forget that it's Ethers, not Ether. So probably that could be the problem. New Ethers, not Ether. Let's refresh this again. Select apples and then good. So everything should be working fine and good now. So we are voting for Apple. The chairman is voting for Apple. So let's add some gas. Let's get some gas fee. For faster transaction, we select that. You can see contract interaction. So let's hit the confirm button. Okay, here is the result of what we displayed. Object. Okay, let's wait for that transaction to get mined and let's refresh our page and see if everything is working as we planned. Let's wait for the transaction to get mined and confirmed. Good, transaction confirmed. So let's refresh this page and hopefully our poll should increment by 1. Good, so you can see the chairman has voted for this campaign, Apple. Now the next thing is anybody can vote now, right? So we can we're not going to call this function, but we're just going to do it here. So we're going to give right to vote to another address. So let me just say the second address. I'll just pick the second address and give right to vote here directly from the Remix IDE. So I pick the second account. Let me just drop them here. This is the contract address. Second, sorry. I wanted to copy the second account. Copy the value of the second account, drop it here. So I call this second account. Let's pick the value of the third account. Let's pick the address. Third account. This is from my MetaMask. You can easily create an account in MetaMask by just clicking the create account button. So let me click the fourth account. Let me create the fourth account. You can see by clicking this create account, you can just easily create an Ethereum address on MetaMask. So let's pick this fourth account. FOURTH, fourth account. Okay, all right now. So the chairman wants to give access to these accounts for to vote. So he's going to give the second account and third account. So we'll pick this second account. And then we're going to give him right to vote. So you can actually call this function 2 on your interface, and just the way I call the vote function and pass in this parameter to call this function. So let's give this second account. Gas estimation failed, and you know why? That's because this operation was performed by an address that is not designated as the chairperson, so which is the first account. So let's change it to the first account on MetaMask. You can see this is the second account, so let's change it to the first account, which is the original account that deployed the smart contract and the chairman of the smart contract or of this campaign. So we've changed it to the first account. Let's hit the give right to vote button, and that should pop up MetaMask. Okay. Okay, we can add some gas to make this transaction faster. I'll just pick this gas here, pick this gas price here. Okay, so and we can watch this transaction here. So you can see transact to ballot, give right to vote. So this is what we're calling. So we can watch this here if it gets good. So I believe no, it's still pending. Once it's done, we should see a check button here, right? Let's check it on MetaMask. Transaction is still pending. Okay. Let's wait for the transaction to get confirmed. Well, this transaction is taking quite some time. Okay, good. Took quite some time actually. Now we've done that. Now you can check the voters by picking that you want to know voters of this. So you can pick the second account that was given access to votes, and then you check voters if you can remember. So you want to see these accounts. You can see a vote weight has been given to this account 1. The account has not voted yet, and the account has not delegated anybody to vote, and the delegates too has not voted. And okay, and the account has not voted, right? So let's also give the third account right to vote. So give the third account rights to vote. So this is calling up MetaMask. Just notice my internet is quite slow. Okay, we can increase the gas fee by hitting the edit button. Select this and then hit save. And hit confirm. Let's also wait for that transaction to get mined. Okay, Okay, good. So now we have given the first, the second, and the third account. The chairman has given them access or right to vote in this campaign. So it means each of these accounts can vote. But now, let's say the second account wants to delegate another address to vote on its behalf. So, and that's what we are going to do now. But first of all, let's okay, so that's what we're going to do. Well, let's check the delegates. What we're going to do, we're going to call this function. Let's do this on Ethers.js. So we're going to call a function called delegates. So we're just going to create that function, delegates. Function delegates, and it's basically the same thing we're just going to pick here. So let's just pick this whole piece of code and dump it here, and then the only thing we're going to change, let's reduce this API. Oh, this expanded all the APIs for me. So the only thing we're going to change here, we see instead of proposal value, we see address value. That's the address we are delegating to vote, which is this. So I can change this to text address. That's the address from the text box. So see address value, right? So this should be text address. And then delegates votes. Let's change this to delegates votes. So contract dot delegates, and then this should be address value. Okay, so this should be delegate votes. Good, I think this is okay. So we're going to call this function on our button. So I'll click. Delegates. So the second account is going to delegate the third account to perform this action on its behalf. So we're going to copy this and then make sure that we are signing to MetaMask with the second account. So account number 2, and then we are going to delegate that's the last account, the fourth account, to perform this on our behalf. So I put in the contract address, the fourth account address here, and then I hit the delegate button. So okay, good. So this pops up MetaMask. So we click on this, fast transaction, hit the save button, and then click confirm. Wait for that transaction to get mined and see the results. Good. So we have delegated a third account to perform action to be able to vote on our behalf. So let's go and this is the second account here. So let's check the voters details. Let's call this. So you can see weights 1 voted true. It means these accounts cannot vote again. The second account cannot vote again because that's delegated someone, and that's why the voted Boolean value has been toggled to true. If you look at the account requirements we have here, and then the address that is delegating is this address. So this address, which is the fourth address, is the only address that can now vote on behalf of the second account, and that address has not voted yet. So let the third account vote, and then the fourth account votes. So we're just going to do that now. So let's check the third account. Let's vote for maybe mangoes or maybe oranges. So the third account is going to perform its voting. It's going to vote for a campaign, for a proposal. Third account is voting for oranges. Now imagine if this is a company, and you should know that you should know that if it's a company, just imagine, okay, it's a company where each of these addresses are shareholders and they want to vote for a campaign like this. But you should know that if it's in that kind of scenario, not all addresses or not everyone in the company will have the same voting power. So you could say maybe the second account is or maybe the chairman has 2 voting power, the secretary have 1 voting power, the rest has 0.5 voting power, just anything like that. You can think of that. So the third account is voting, and it voted for oranges rather. So if transaction get mined, we can refresh these and see. Can watch that on MetaMask. Pending. Okay, good. So that account has voted. So let's refresh this. So you can see that account has voted for oranges. Now, the account that was delegated to vote will not be the account that will do the last voting. So let's sign into the last account, which is the fourth account, right? That was delegated to vote by the second account. So this account is going to vote. Let's say this account voted for apples too, or for oranges. Let's say apples. So we hit the vote button. Increase the gas fee. confirm button. And then wait for it to get confirmed. Good, so that gets confirmed too, and then we can refresh this. So you can see, so Apple has the highest votes, Mango 0 votes, and Oranges 1 vote. So if we come here, since we didn't call all the functions we have on our smart contracts, we can just get to see all this here. So if you go right ahead and hit the winner name, you want to see who it. You can call this on your web application actually, but if you look at it, the winner name you can see is Apple, so it has the highest vote and it's the winner of this decentralized voting that we did. So okay, all right, so we're able to create this application and then we're able to vote for different proposals, and we have our results here, and we're connected to this smart contract via Ether.js instead of web3.js. So thank you for watching. Welcome to the concluding part on this video series where we'll learn Ethers.js by creating a decentralized voting application. My name is Ayuba Ojanogwamu-Azu, and to have you run through the recap of what we did, the first thing is that we looked at the overview of Ethers.js and our voting application in general, and we said the Ethers.js is a library, it's an alternative to web.js, where web3.js rather, where you can interact with the Ethereum blockchain through Ether.js library that was created for you. And I said the easiest way you can learn Ether.js is by reading docs, but of course, if you read the docs, you might not really get to understand everything. So watching a video tutorial like this will save you a whole lot of time, and you get to see the steps, the necessary steps that you need to take to use Ether.js to interact with your smart contract. Then after that, we went ahead to create the app interface, in which we have this. Voting the app interface, in which we have this. So we created these in HTML and CSS. Then from there we proceeded and then created our voting smart contract. It's a popular voting smart contract that you see once you hit remix.ethereum.org, but we just did some few modifications here and there to fit into our application. Then after that, we of course interacted with our voting smart contract through Ether.js, which is the core purpose of this video tutorial, and we learned some few tricks here and there on how we can get things up and running. So if you've watched it up to this level, congratulations on becoming an expert in Ether.js. Once again, my name is Ayuba Ojanogwamu-Azu. I'm a software developer from Nigeria and a blockchain engineer, and thank you for watching.